Hello and welcome back. We are doing week 5 ArrayList and collections. We're going to finish off this topic by, sorry, we're going to finish off this topic by talking about wrapper classes and how we can get ints and booleans and doubles and all those other primitive types into ArrayList. Let me just move my little floating meeting controls. Okay, so we covered the first 3 learning objectives around array lists in my last video, where we actually talked about using array lists, learned some of the different methods, and compared them to arrays. So now we're going to talk about how we can actually get some primitive types like ints and doubles into an object type, so making them into class types rather than primitive types, so that we can use them in arrays and possibly in other scenarios. And we've actually already seen a little bit of this before. We just didn't realize that's what it was. So consider for a second the capital I integer. Think about it like when we do integer.parseInt. An integer object is a tiny object that contains a single integer. So that integer object that has things like integer.parseInt or integer.toString maybe is one, I think. I can't remember. There's lots of integer level classes, and all there is inside of it is one piece of data, which is an int. So consider for a section our person class that has a string name and an int age. Think about an integer class that has just one variable, an int n, inside of it. And it wraps itself around the tiny little int. Another great example of this is when we did our person list and we made an object person list that all it really did was like sort of encompass the partially filled person array and then housed all the things that you could do with it, but it really was just an array. That's the same thing here. We're wrapping our tiny int in this integer class object. So Java provides these wrapper classes for all primitive types. So we have int, double, boolean, char, long, float, short, and byte. And if you do capital letter for all of them, you end up with their object types. Char becomes capital C character, but all the others are just, and capital I integer for ints, but all the others are just capitalized the first letter. Now, each of these are actually storing references to immutable objects, just like a string. So this is why string has always seemed kind of unique and different. When we talked about strings, we said technically it's a capital S string. Technically it's an object, but it's immutable. We can treat it like a primitive. Every time you make a change, we get a new one, just like you do with primitives. You can pretend like it's being passed by value, even though it's not being passed by value. And again, that's because it's immutable. So all these primitives were also in theory immutable because they're primitive values. It's not even really a word that we would think to use with a primitive value because of course it's immutable. You always get a new one. But that's like the mutability of something is typically more associated with objects. And so we actually do have objects that are immutable available to us for each of the primitive types. Now, string is the only primitive, like air quotes, primitive type that doesn't have an actual primitive type associated with it. All the others have these wrapper classes. And this is because secretly under the Java hood, strings are basically just character arrays. But we don't want to have to use them as character arrays. So that's just never really given to us as an option. So these are all available to us to be used. You don't even have to pull anything extra in. So let's just take a look at what that looks like. We have 2 variables here. We have an int I and an integer I object. We can assign I equal to 5. We can assign the I object to a new integer 5. So just like you would make a new person, you can make a new integer. You can use the I variable as we know how. We can use our object variable. In order to use our object variable, we actually have to use like a getter to get that value out of it. So we have our iObject.int value. So that's kind of like saying .getName or .getAge, only with the built-in integer class, it's called .int value, and we can add 1 to it. And if we want to change the value, we can say I equals 3 or iObject equals new integer 3. So we can see sort of how the storage is different. When we just use the variable I, it's stored on the runtime stack. It's stored not as an object, but as a primitive value. Whereas I object is going to be stored in memory. It's going to be stored in the heap memory, and it's going to be stored as an object. So like other things around that int value. We can see that when we use them both appropriately, they can both print 6, no problem. And then we can see the difference here when we change the value and I equals 3, the 5 is gone, and it doesn't quite get orphaned. That's not really how it works. Whereas with the I object, we do see it getting orphaned, like the previous 5, and now we have a new value 3 in our I object. So the thing is, when we look at that code, wrapper classes are super clumsy, right? We have to use the new keyword everywhere. We have to call iObject.int value just to get the integer number out. That's a lot of work. And with strings, we don't have to do that. We just say string s equals hello or whatever it's going to be. We never had to say string s equals new string hello in the brackets. We never had to do that. So for a long time now, Java now actually does all that conversion for you. So just like strings, you can use the integer wrapper class, the double wrapper class, the Boolean wrapper class, just as you would a primitive, and it will work perfectly. So you don't have to say new, you don't have to call .int value, Boolean value, etc. You just use them normally, and Java will like unbox, so unobject the integer value or the value of the object when you need it. And when it's expecting an object value, but you're giving it just like a basic primitive, it will box it up nicely for you and turn it into an integer or whatever data type it is. So strings were already doing this for us. Strings were already boxing and unboxing the data for us without us even realizing it. Now we're able to do this with integers, with doubles, etc. Now, the main difference is, of course, from our perspective, where these are stored, right? We just saw this picture and how they're stored differently. So it's important to notice this because we don't need to be using capital I integer everywhere. If we do, we could be using up more space than we need to in our heap. And while on our computers, like efficiency is pretty negligible, in theory, retrieving values from the heap memory is going to take longer than the runtime stack memory. So while it's an option to use capital I integer everywhere that you were using int and your code will still work just fine, we typically don't do that unless we absolutely have to put it in, like in ArrayLists. So when we are expecting that int value and we give it an integer, it's going to just throw the value in appropriately. And if it's expecting an integer, but we give it an int, it will box it up and create an integer, capital I, with that value. No need for the keyword new anymore. So it looks something like this now. So int x equals new integer 34 is a very silly thing to write, but in theory you could, because the new integer with 34 inside of it would get boxed up. And then when Java realized you just need the 34, it would unbox it for you and put that over in the x variable. You can say integer y equals 45, and that would be the same as saying integer y equals new integer 45. And we can see how we can sort of swap between lowercase I int, uppercase I integer variables, and it just sort of figures it out for us as if they're interchangeable, which is really quite helpful since most of the time all we want is lowercase I int, but there are scenarios where we're forced, like ArrayLists, to use capital I integer. Okay, so here we're using the primitive and the object integer variables again. So in I and integer I object. However, now we're not going to be explicitly calling new integer or that .int value method. We just removed that, and now we're just using them just as if they're plain ints, and it works perfectly. Just now, and it works exactly the same as before. Like we're still going to get that spot in memory. We're still versus like the runtime stack. We're still getting like orphaned information at the end. Like all of that's still the same, but from our perspective, this is obviously much cleaner because now we can just use int and integer exactly the same, and we don't have to worry about boxing and unboxing the data so explicitly. So now when we make our integers with an array list, we can say ArrayList capital I integer. Now, a quick reminder from the previous video, I really only showed how to make array lists out of like random capital O objects, but also like strings. So now we can actually see how to use array lists, not just for strings, but for these other data types like integers. So we have array list integer, capital IL is equal to new array list, capital I integer. And again, we don't have to say new integer 5, new integer 7, new integer 9, right? We can see that we can just say dot add, dot add, dot add as ints, and it will box it up into an integer for us. And how we know that that's what's happening is because if we look at the picture below, you'll see we have an integer array, like an int array, and then an integer array list. Both have 3 elements in it. The default size here, it looks like for the array list is going to have some empty spaces, but that's fine. And the array list and the array itself only has 3 spaces, but we can actually see how the data is being stored in memory is very different. Because in our array, the ints are stored in each of those memory spots, whereas in our array list, each of those indices is storing a reference to the integers. So it's different. This is different under the Java hood, right? We can see with the arrows, a very fundamental difference in how this information is being stored. Okay, so we can see here when we change the array at 0 to 4, the array at 2 to 8, we just replace those values, right? These are primitive values. They just get replaced as is. But when we do it on the array list and we use .set, we're implicitly unpacking and repacking those wrapper class integer values. So we do end up with orphaned information, and we do end up with new objects with new memory addresses for 4 and 8. So again, we can see that there's a little bit more overhead that comes with using the integer wrapper class than just using ints directly. But of course, using the array list can often be helpful enough that it's worth it, basically. So array lists are really convenient, and they're giving us a lot of useful methods, like how they grow and they shrink, and we don't have to micromanage that like we did with partially filled arrays. But there is a lot more complexity internally, right? And while our computers these days are very fast, it does actually translate to a speed penalty. Like there is definitely a difference. So for our computers, definitely in this class, we're not going to notice any difference in terms of speed. But imagine on very, very large data sets, there actually is quite a difference between retrieving information from the heap memory versus using primitive values, things like that. So typically ordinary arrays actually are preferred, but this really gives us a glimpse into understanding why it's important that we actually think about the problem space when we pick our data structure. Do we want to use an array? Do we want to use an array list? Well, what are we going to be using it for? When we start to talk about sorting and searching in the next set of videos, we're going to talk more about this to ask ourselves, do we need to sort our data? Should we be sorting our data? So really starting to ask ourselves the questions that allow us to design our problem space in a way that's going to be efficient. Because again, in a classroom setting, it's pretty small potatoes. You're not really going to notice a speed difference, but out in industry, in the real world, in computational research, you might actually notice a difference if there's a lot of sort of computationally intensive tasks. So we did do this the other day where we had the array list object class, and we saw that we could put anything in it, right? It allowed us to put strings in it. That's how I used it when I made my array list user defined array list class. But you can put anything in it, anything that falls under the object, big O object umbrella. So we talked about how if we wanted, we could even make an array list of exceptions if we wanted to for some weird reason, or an array list of integers, or an array list of, pardon me, person objects if we make a person class. But because all of those fall underneath the object, big O object umbrella, we can actually mix and match them, which means an array list can store information like a person in the first spot, a string in the second spot, and an exception in the third spot. An array list capital O object can house all of those because those are technically all kinds of objects. They all fall underneath that object umbrella. Now, I don't recommend doing that for lots of reasons, but there is a lot of power and flexibility in understanding that that's a thing that you can do. And in fact, most dynamic interpreted languages do just about everything this way. So in future classes and weeks where we are going to sort of start to touch on the power here and how to use this ability of like mixing types, air quotes, mixing types, how we can like use that to our advantage. But a lot of it comes also in the next course, in the Comp 2140 course next. However, even with understanding all of that, it's also important to know that that means, and we saw this in our string example, when we make like a get variable, when you get an element out of an object array list, you're just going to get an object. So if you store strings and integers and people and exceptions all in an array list, and you call .get I 0, the object you get back will be of type big O objects, and it could be any of those objects. It could be anything underneath the object umbrella, which means you can't really do anything with it until you actually know what type it is and you cast it into the right type. And in order to do that, you end up having to do a lot of extra checks. There's a keyword instance of that you can use where you can check to see if you have an instance of a string or an instance of a integer or an instance of a person class or an instance of an exception, right? So there are ways to use the object that we get back and to cast it appropriately, but there's lots of extra work that has to happen in order to make that function the way we would expect it to. So in order to do that safely, there's a lot of extra work. So we're not going to see that keyword right now. We will see it later. It does exist. It is a thing that can be done. But for right now, we're really just thinking about array lists as dynamic arrays that store homogeneous data. So the same data type data. And in a couple of weeks, when we start to look at more things under that capital O object umbrella, and we talk about a few other sort of interesting ways to manipulate objects, we're going to see a little bit of mixing data types too. And so we'll touch more on this at that point in time. So my pause and practice for this set is really, really easy because really all we talked about was wrapper classes. So go back to all of our array practice, any question that we've done already in the last 4 weeks, and just rewrite those problems using array lists instead of arrays. So all your int and double arrays can now become integer and capital D double array lists. And that's a great way to practice using array lists. And I actually strongly recommend it because having that dynamic change of value can actually sort of, there are some pitfalls that come along with it. Like for those of you who actually did my pause and practice after the last set of videos, and you were supposed to delete duplicates from that array list, perhaps you fell into some of those pitfalls where when you delete an element, everything shifts over automatically. And all of a sudden your size changed in the middle of your for loop and crazy things can happen. So I do actually recommend, even though maybe it seems a little bit simple, I do recommend going back to some of that code and rewriting it using array lists just to get a feel for them and to get some practice in before things start to get crazier with the coming week's topics. Okay, yeah, so I don't really have any source code here to show for this since I am just saying to go back and just swap things out for array lists. But as always, the discussion forums are always open if you do want to ask questions about doing that or how to use it properly. And until next time, thanks for watching.